Welcome back. I hope you guys had a good weekend. We're going to continue using our molar mass type calculations. So you are going to need your periodic table and a calculator. So go ahead and take a second and pause this video if you need to get those resources out. So molar mass has a purpose, and so we started out last week with conversions using atoms and molecules to the mole. So Avogadro's constant is useful, but in most real life applications and where we use this information a lot is working with grams. Like I mentioned before, a really big application I use moles in everyday life when it comes to chemistry and getting things ready for lab is to make those solutions. I need to know the molar masses, and then I work through mole conversions to then make those solutions that you use. So how in the world can we use molar mass? So molar mass is a conversion factor. Like Avogadro's constant, that's 6.022 times 10 to the 23rd atoms or molecules to a mole, works the same way with molar mass. So if you look at magnesium on your periodic table, you will see that it has an atomic mass of 24.31 grams. So that means to have 1 mole of magnesium, you must have a mass of 24.31 grams. So there's 2 ways we can set that up into a conversion factor. So the big thing is, it says that it's per mole. So we can say that we have 24.31 grams per, remember per means divide, 1 mole. Vice versa, we can say that if you have 1 mole of magnesium, you have 24.31 grams. Okay? So any element off the periodic table, you can just look up its mass, and that is its molar mass. I stressed working on how to calculate molar mass from things that are compounds, because that's where it gets a little bit trickier on making sure we understand where that information comes from. So we're going to kind of just dive right in with our first example, working out a conversion. So the first thing is we have the silver metal. It's a lot of times used to create jewelry. So if a piece of jewelry requires 0.75 moles of silver, how many grams are needed? Just like when we did Avogadro's conversions earlier last week, we should be able to identify a given and what it's asking us to solve for. So our given, it's important to recognize that it's 0.75 moles, but also what it's of. So we have silver. The next thing that we need to know is what we're solving for, which is grams. As we get started, I can write my given 0.75 moles of Ag. And it wants to know how many grams. So that means we need to know the molar mass of the compound that we are working with. In this case, it's not really a compound, but it's an element. So and I'm going to abbreviate molar mass as MM for molar mass of Ag. So if you want to take a second and pause and find silver, you would discover to 2 decimal places the molar mass of silver is 107.87 grams per mole. That's my conversion factor. That per mole will always be per 1 mole, nothing else. So because my given unit is moles, this piece is what's going to go in the bottom here. So 1 mole will go into the bottom. The mass is what's going to go into the top part of my conversion factor. So what I've done here is just separated out the molar mass into a conversion factor. If you look, moles is in the top and bottom, the mass is in the top, that's what we need to multiply by. So if you take 0.75 moles times 107.87, you get approximately 80.90 grams. And like last week, it's good to include what it is, and that is silver. So we have 80.90 grams of silver required to make this piece of jewelry. So the other 2 examples are working with things that are not in element, but instead things that are compounds. So we have this box of salt contains 737 grams of sodium chloride. How many moles of table salt or sodium chloride are present in the box? So again, we can see we have a given. In this particular style problem, the given is going to be a mass, and also the formula for it, table salt. So I can go ahead and write that out, 737 grams of NaCl. And it wants to know how many moles we have. So like before, we need to find molar mass, like I had you guys practice last week, Thursday and Friday. So what we do with a compound is, if you remember, we list out the elements that make it up, and we take an inventory. So we have 1 sodium and 1 chlorine. That's when you then access your periodic table. Sodium is 22.99, and chlorine is 35.45. So basically we just have to add those two masses together and we get a molar mass of 58.44 gram a mole, or grams per mole. Again, that's my conversion factor. This problem is different because we are now starting with grams versus the previous problem was moles. So because you have grams, that means grams must go in the bottom. So 58.44 grams is going to be the bottom part of the conversion. The other half, the other part of the conversion factor is always 1 mole. That's coming from this per mole part of the mass. So in this particular example, we need to divide in order to solve. So if we take 737 divided by 58.44, we get an answer of 12.61. And our unit, because grams have eliminated, is moles. And again, getting in that good habit, this is 12.61 moles of table salt. Last example then is working with another compound. It is ammonium sulfate, and we have 100 grams of it. It wants to know how many moles do we have. So again, the first thing we're going to look at is what is our given. It's mass, and it's of that compound NH4,2SO4 or ammonium sulfate. And we want to find moles. Very first thing, because I know I have grams, I'm going to go ahead and start working on my molar mass. And it's of this NH4, 2SO4. So you want to be just a little bit careful in taking your inventory. So we can see we have nitrogen, hydrogen, sulfur, oxygen. We have a polyatomic inside a set of parentheses, that ammonium. So remember, you distribute that by multiplication. So we have 2 nitrogen. We are not going to have 6 hydrogen, but we're going to have 8, because again, you're multiplying it in. So 2 times 4 gives me 8 hydrogen. 1 sulfur, 4 oxygen. Looking up each of their individual masses, again, just round them off to 2 decimal places. Nitrogen is 14.01. Hydrogen, again, we just use 1. Sulfur is going to be 32.09. And last but not least, oxygen rounds to 16. So again, you can put this in all at once. If you multiply, add everything up, you get an answer of 132.11 gram per mole. So now that I have that piece of information, I can go ahead and start working on the actual conversion. So my given is 100 grams of this ammonium sulfate. I can go ahead and set up my conversion factor. Notice our given unit is grams. Therefore, grams needs to go in the bottom. So that 132.11 grams will be the bottom portion of the conversion factor. The top piece, again with molar mass, it's always the mole, and it's always 1 mole of it. So to work this through, much like the last problem, our given unit is grams. I can eliminate those. Looking at the conversion factor and how it's set up, you must divide. And so if you take 100 divided by 132.11, you get an answer to 2 decimal places as 0.76 moles. And again, including that a label of what it is, the NH4, 2SO4. So if you have any questions, feel free to reach out to me. Again, what your practice will be is 4 problems working through what we just did. Make sure you look at what it is, what it's asking you to find, and make sure you're careful and that those units cancel out.